Hey, Christy.
Hey, James.
So I've just got back from time traveling into the past.
You're traveling back in time? Did you go to the dinosaurs? Did you see a dinosaur?
No, I only went back 5 years. I didn't want to get stuck back in too far back.
I guess that makes sense.
I actually traveled back to a festival, and this is me in that festival 5 years ago, thinking about the current landscape of CICD.
Wait, what festival were you at?
This is Glastonbury in
Oh, I
2014.
I was there too.
Look at that for a coincidence. So, what were you thinking about at this time as well?
I was obviously thinking about CICD.
Right, okay. So, it was pretty scary. CICD back in 2014, it's bash scripts everywhere. I'm pretty happy to be back here in the present time.
I don't know, James. I mean, I've been seeing a lot of CI recently, and I think it's still kind of the same.
Okay, this is kind of crazy, right? This is 2019. Everything's cloud native. We can do better than this. So we're here today to talk to you a little bit about some of the projects that we're working on. Shall I start off by introducing myself?
Yeah.
So James Rawlings mentioned that it's me again at the start. So working on a project called Jenkins X. We've heard a little bit from Carlos. When you talk about Jenkins X, you have to Jenkins X. Okay, we have to do a thing. It's a thing we do. So yeah, that's me on the left-hand side there. I work for CloudBees on the open source project.
And hi, everybody. I'm Christy Wilson. I'm a software engineer at Google. Throughout the years, I've worked in a lot of different industries. I've worked in mobile, I've worked in foreign currency exchange, I've worked on AAA games, but no matter where I go, I always seem to end up gravitating towards working on testing and CI/CD. So these days, I'm really excited to be leading the Tekton project.
Okay, so we're going to try and go through a couple of things today. We're going to have a bit of history around about Tekton and Jenkins X as well. And then, as it's KubeCon, we're going to try and dive in a little bit to a few more details. And we're going to have a demo, probably not a live demo. We may chicken out and do a recorded demo, but we'll see. And we're going to have some takeaways afterwards.
So let's talk a bit about the history of Tekton. So to do that, we have to travel all the way back in time to early 2018. So in early 2018, the Knative project started. And part of that was Knative Serverless, which is all about an open source serverless solution built on Kubernetes. So in order to make that work, they needed a way of going from source code to deployments, which is what Knative Build was created for. And people really liked Knative Build because it turned out they really liked just building images on Kubernetes, but they quickly wanted to do more. They wanted to be able to run tests before building the images, and they wanted to create more complex pipelines. So we created the Knative Pipelines project. And then as that got bigger and bigger, we split it out into its own org. And so now it's the Tekton Pipelines project, and it has other projects popping up around it. Remove or enable? Can we just, okay, leave that in the background. So Tekton is all about creating a CI/CD spec that works across vendors. So it's taking a lot of what we've been doing with CI/CD already, but adding a declarative model on top and adding types. And one of the really cool things that we want to do is make it so that you would eventually be able to go to a repo and you can really easily run their entire testing and deployment pipeline against your own infrastructure. Or you can take pieces of that pipeline and reuse them in your own pipelines. And even though we started with just pipelines, we have expanded into multiple projects. So we now have a CLI project, we have a dashboard project, and we've recently started working on an event triggering project as well. And we have regular contributors from more companies even than are listed here, but some of the people that are contributing regularly are CloudBees, Red Hat, IBM, and Salesforce. And if anyone here is interested in contributing, we've tried to make it really easy to ramp up and get started, so please join us.
Okay, just do a bit of history around for Jenkins X as well. So people are familiar with Jenkins. Jenkins itself is a phenomenal open source project. It was created back in 2004. It's got, we estimate, well, there's 200,000 Jenkins servers that we know about running. That figure is actually expected to be more likely to be 1 million. There's also 15 million Jenkins users out there as well, which is, for an open source project, that's tremendous success. But we know that there are some challenges with, say, the advancements around technology, around, say, containerizations and microservices. There are new architectures that which we could be embracing, where Jenkins is possibly struggling with, well, due to some of the successes. For example, the plugin model. It's amazing because there are thousands of plugins that people have developed and contributed to the open source community. But that also means you can install 1,000 plugins into your Jenkins server, which can then lead to issues. It uses a JVM. When we're talking about the cloud as well, lots of memory usage that causes extra costs as well, and also instability as well if you've got lots of plugins running different class loaders. So we also have an issue with, say, scaling number of jobs. We've got this concept of a noisy neighbor. I don't know if that's a common one here, where if I'm developing on the team, I'm running my pipelines. If I was to develop or introduce a problem with my pipeline, that actually gets executed on the Jenkins server. Another team in the organization could then start to be affected by that running, because their pipelines are running on the Jenkins server too. So if I actually introduce a bad change, that could have a negative impact on other people's changes, on other teams. So Jenkins X builds on the successes of the open source project of Jenkins. We want to take the same concepts and principles as well, really empowering developers to have better, to be able to deliver software faster and with smaller incremental changes. So we know that Kubernetes is quite a phenomenal project, open source project as well. Jenkins X looks to provide a developer experience and a consistent way of working across different projects for Kubernetes. We've also, with Jenkins X, we saw Carlos actually demoed, and there was a great question around the JX CLI. We have a command line interface for Jenkins X, really helps us with rapid development. You can create or import projects from your source code repos onto Kubernetes. And Jenkins X will actually add everything that's needed to be able to build, package, run your software. We've also got the concept of environments as well, so this is something new from Jenkins X, you'd say, where we're actually deploying our applications into, say, a staging or a production environment as well. Also the concept of preview environments, which Carlos mentioned, ways to really collaborate on pull requests, deploy your changes into it, and actually then run automated testing and have greater control so that when you know that you can be more sure that when that change merges into the master branch, that can actually be shipped and delivered out to your target environments. One of the other really, really cool things around Jenkins X is that we support pluggable pipeline execution engines. So Jenkins being one of them, but also the new Tekton-based pipelines as well, which leads us nicely into Tekton. Just a quick show. This is where our own journey for Jenkins X started. So we started out running static Jenkins servers, but as we know, we're looking to the cloud, then that can actually introduce extra costs. So we actually looked at bringing other open source projects like Prow that's able to trigger our builds. And then, like a gift from the gods, Tekton Pipeline came along towards the end of last year that we actually embraced it and adopted this. And this really gives us much more scalable and reliable and cheaper cloud builds as well.
So now I'm going to talk a bit about what Tekton actually is and how it works. And I'm going to get into some details. And because it's KubeCon, I'm going to talk about some of the technical challenges that we've had around Kubernetes as well. So the first thing to know about Tekton pipelines is it's implemented with CRDs. Is anyone here using CRDs right now? A little bit. Is anyone using them in production? Cool. Okay, so you already know about this, but as an overview, CRD stands for Custom Resource Definition. So this is a way of extending Kubernetes itself. So out of the box, Kubernetes comes with a bunch of types like pods, deployments, services, but you can add your own types as well. And so there's actually two pieces to this. So you define your types, the CRDs, which are specifications for resources, and then you define binaries called controllers. And then when you put those two together, it basically lets you build declarative APIs on Kubernetes. And so what a controller is doing is it's basically constantly running, and it's looking at the desired state of the system, which is in your CRDs, and then it's waiting for something to happen to the CRDs. And when they're created, when they're updated, when they're deleted, the controller is notified, and then it checks to see what needs to be done to make the reality actually match the desired state. And so if you're implementing a controller yourself, there are a bunch of different libraries that you can use to do that. They kind of fall into two different camps. There are the ones that are based on Client Go, which does a lot of code generation. And then there are the ones that are based on the controller runtime. So that's libraries like Kube Builder, which instead of generating code, do a lot of dynamic code introspection for you. And so what we're using for Tekton is actually the Knative PKG library. And that's because we came from the Knative project and because it works well. So we've just had no reason to change. So let's talk about pipelines in particular. The most basic component of pipelines, and this goes back to the question earlier about like what do the pipelines actually look like, so you'll kind of get a sense of that. The most basic component is a container spec. So this is an existing type in Kubernetes, which is what image do you want to run and what arguments do you want to run it with. So the first new type we add is called a task. A task combines images and runs them in the order that you specified them in, and we call those images steps. So a task is a series of steps, and they run on the same Kubernetes node. Our next new type is called a pipeline, and a pipeline combines tasks. And you can run tasks in any order you want. You can run them sequentially, you can create complicated graphs if you want, and they're not guaranteed to execute on the same node, but you can still pass inputs and outputs between the tasks. So pipelines and tasks are types that you define once and you use them again and again. To actually invoke them and make something happen, you use our next two types, which are called pipeline runs and task runs. And those invoke pipelines and tasks. And our final new type provides runtime information, like what image registry should I be using, what Git repository should I be running against, and that's done with pipeline resources. So altogether, there are 5 CRDs that make up Tekton pipelines. There are tasks that are made of steps. There are pipelines that are made of tasks, and then you run those using pipeline runs and task runs, and you provide runtime information with pipeline resources. So those are all of the types that we've defined. And if you want to see some examples of what those look like, we have a catalog repo that has tasks which you can reuse in your own pipelines. So let's talk a little bit about some of the more interesting Kubernetes specific challenges that we've had to overcome in order to implement this. So the first one is, I was mentioning that tasks run steps in order. So this means you're executing containers one after the other, and each one has to wait for its turn to run. It turns out that this is not something that Kubernetes just supports out of the box. This is kind of a different model of execution than most people are using. So I want to thank a number of people for the solution that we have to this right now. I want to thank Nader, I want to thank Jason Hall, Aaron Prindle, the other James, well, you too, of course, but the other James specifically, and the people who implemented Prow, who came up with the solution initially. So basically what we're doing is every time you specify a container that you want to run, we inject a binary into it, and then we run that instead of whatever it was that you were trying to run. And then that binary will wait for its turn to run by looking at the file system for a file to exist that signals that it should actually start. So instead of running your binary, we run our binary, and we wait until it's that step's turn, and then we invoke whatever command you were actually running. So it's fairly hacked, but it works well enough for now. The next challenge is about sidecars. So a sidecar is a container that runs alongside whatever containers you actually want to run. And if you have experience with Istio, you'd know that in some situations, Istio will inject sidecars into your pods. And it turns out that since we want to run a bunch of containers and then stop after they're done, sidecars actually cause some problems for us because as far as Kubernetes is concerned, if the sidecar is still running, then your pod should be kept up and the pods just stay around indefinitely. So we have a couple solutions to that. We basically, and I want to thank Alex DiCarlo and Scott Seward and Jose from CloudBees for implementing the solution to this. So what we do two different things. First, we use something called the downward API. to wait until all of the containers are ready to run. So that's something that Kubernetes provides that lets pods introspect the state of Kubernetes itself. So they can read from the files, containers can read from the file system and know when all the containers are ready to run, are ready and running. And then we also actually observe when all the steps have completed, and we change the spec of the sidecars and replace the binary that they're running with a no-op binary that just finishes immediately. So this is more hacks, but it works. And we're looking forward to, I think there's a proposal for first-class support in Kubernetes for sidecars, which hopefully will make it so that we can remove this and just use that instead. And then the last challenge that I want to talk about is about inputs and outputs. So I was mentioning before that tasks do not execute on the same node, but you might sometimes want to take data that's produced by one task and pass it to another task. So that's kind of a challenge. And what we do to make that happen is we have two different solutions currently. So the first one is that we create something called a PVC, so a persistent volume claim, before your pipeline executes, and then we provide that to any tasks that need to share data so they can write whatever data they want to that volume, and then the volume will be attached to any pods that run later that want to read it. It turns out that creating and attaching PVCs is a bit slow though, so this is not a great solution. Our other solution is to upload data to a blob store like GCS in between tasks, which, as you could imagine, is also quite slow. So both of these solutions are fairly slow. They do what we need, but they're not efficient enough. So theoretically, we'd like to explore making this a bit better and maybe potentially just scheduling tasks onto the same node when we need to do this, so they can just use the disk directly. So if you have any ideas, we are totally looking for more ideas around that. And I also want to thank Nader and Shash from Pivotal for implementing both of these solutions. And yeah, so that's it for nitty-gritty details about Tekton. Do you want to talk a bit about Jenkins X?
Sure, thanks. Okay, so as you can probably guess, Jenkins X loves Tekton pipelines. Really is a way that we can embrace the cloud using more reliable and more scalable and cheaper ways of actually running our pipelines. So Jenkins X also uses Prow. Prow comes from the Kubernetes ecosystem. Every single Kubernetes GitHub repository has Prow enabled. So Carlos showed before where you can approve and you can have chat ops on pull requests. This is really just firing and triggering these builds within the cluster and then triggering pipelines, Tekton pipelines. Jenkins X wants to really want to embrace the those 15 million Jenkins users. We obviously want to be providing something that's familiar to those 15 million Jenkins users. We have a Jenkins X YAML file, which is a declarative approach we'll see in the demo shortly, but using the same terminology and concepts that all those Jenkins developers will be familiar with, stages and various other blocks as well. You can see on the right-hand side there's a kind of an example. It also allows us to embrace things like Canico as well, which is a much more sensible approach to actually doing Docker builds when you're running on Kubernetes. We have the concept of build packs. So this is where you can actually specify a repository. We have an open source repository, but then you can actually customize your own one as well. Build packs have a collection of different languages, for example, a set of, say, Helm templates, Docker files, and pipelines that you can actually kind of maintain a shared group of these build packs and then apply them to when you're creating or new or importing existing applications. So a build pack you can inherit, and you can also then override different steps and stages. Or you can have no build pack at all and just hack on your Jenkins X YAMLs directly. Jenkins X uses Jenkins X to build Jenkins X. We've actually moved over all of our repos to using Tekton pipelines, and the benefits have been pretty huge, pretty dramatic. So really kind of just want to hopefully hit that home that people understand that this is really something we're very, very happy with and we kind of love it. Just a little note on Prow, another note on Prow. Prow probably wins the award for having the most nautical themed components. I think it's pretty cool. But this is something that was really hoping to, as it's part of the the Kubernetes testing SIG. We're looking to try and embrace more of this, or maybe working in another project potentially as well to try and take those lessons learned as well, and maybe involving something with the CDF or something. But this is really kind of cool and really allows us to have this extending Kubernetes in the way that it's intended to be extended, and triggering and controlling our pipelines. This is, okay, there's a lot of detail on this chart, but it's really just to demonstrate that we are, with Jenkins X, we are embracing new architecture. This is an event-driven architecture for modern workloads. Really just want to kind of hit that home where we're developing microservices using Kubernetes API server and custom resources, as Christy explained earlier, to have this event-driven architectures with controllers watching for these events. This is Jenkins X being rebuilt from the ground up, actually embracing these modern technologies and architectures. And obviously, from Kubernetes, this is where we actually run, but we want to be doing CI/CD workloads for non-Kubernetes workloads as well. Obviously, anything that's persistent, we want to leverage cloud storage. And the demo I'm going to show you shortly is all using Google's cloud. Yeah. Okay, so I am going to cheat slightly and do a recorded demo. I feel a bit ashamed, but I apologize in advance. Okay, let's skip this. There. Let's do this. Okay, so let me just explain what's going to go on here. So if I go down here, can people see? So we've got ways to create cluster with Jenkins X. I'm using the Jenkins X CLI called JX here. I've typed in JX create cluster GKE. As Carlos mentioned, we've got adding support now for Alibaba as well. This allows us to be able to create clusters very, very quickly. We're also looking at embracing Terraform as well, having more standard approaches of creating clusters. You can see here we're creating a cluster, a load of default questions that we're being asked. And here we can actually install a traditional Jenkins server, or we can use our Tekton-based pipelines as well. So the example we're showing here has got no JVM at all. There's no JVM, it's all Tekton-based pipelines. So we've installed Jenkins X as well, a number of different microservices we saw on that event on the architecture above. We can see we've also installed a Nexus as well, and Prow and Tekton and anything else needed to be able to build and deploy our applications. You can see this is a 3-node cluster. I'm using kubectl at the bottom here, but the JX CLI uses the same approach as kubectl as well to be able to interact with the Kubernetes API server. Okay, so you can see we've got a number of deployments that are running, and here we've got the Tekton controller as well. We've also, out of the box, created some environments, a staging environment and a production environment as well. We use GitOps to be able to deploy changes into these environments so that all changes go via Git and are approved. And we have that traceability as well. Okay, so here we can see this is the Git repository that was automatically created for the staging environment, and we've also got a similar one for the production environment. So we're going to create a quick start of JX create quick start. We're going to use my account to be able to interact with GitHub as well. So we're going to create a brand new project, Git repository, and then we're going to automatically set up all of the CI/CD with Jenkins X. So we're going to, which organization do we want to use? So we want to use a shared GitHub organization here of kubecd there. We've got a selection of really, really basic quick starts. Obviously, you can actually have your own quick starts as well. But here we're going to use I think it's the Golang one. Yeah, Golang HTTP, which is just a very, very simple Golang endpoint that we're going to build and deploy. So down here, I don't know if anybody can see, but we're actually automatically setting up the webhooks after we've created our Git repository in GitHub. So all of that, we've automatically set up all of the CI and CD for this brand new project. Here you can see there's Helm charts. We've got our pipeline as well. And you can see this is really, really, okay, very, very simple, quick start, but the idea is that you can import projects as well, your own source code as well, using the same approach. Here we've got a simple Docker file, just from scratch, deploying our built, our Golang binary that gets built from our pipelines. We've also created the Helm templates. There's a lot of YAML here, so it's really just a way to bootstrap people, but this is all committed into your Git repository for your new application. So once it's deployed, you're then free to kind of tinker and start playing and start expanding and improving that application. So after we, after we actually ran JX create quick start, it was automatically triggered a build. Now this is using Tekton pipelines under the hood, so nice fast builds as well. Let's see what happened. It was slightly sped up for this demo. We can see we've actually deployed into our staging environment. This is the new version. Let's JX get applications. So we can see 001 for JX KubeCon EU was deployed, and it's actually now running in our staging environment. So that was just based on our creating JX create quick start. And we've had all the automated CI/CD set up as well. So we can go into this change because we've got that repo cloned locally. We can check out a branch, make a change, and then push it up to GitHub and actually make a pull request, which should automatically trigger our continuous integration. So here we're just doing a checkout of a work in progress branch. And we're going to open up, is that my? Oh, yeah. Sorry. Yeah, not part of the demo. Okay, so we've also going to open up our project in IntelliJ. Let's go, forget what's going to happen here. So this is our very simple main.go. We're just going to change it slightly. Changing the title. As you can see, no guesses where I was when we did this demo. All right, okay, so now we're going to go to our Jenkins X YAML file. So we can see we're actually inheriting from the build pack, the Golang build pack, which is, okay, kind of cool. We've got a shared place where we can actually maintain our pipeline for building Golang applications. But what's really amazing about this approach now, that we've actually got code completion for editing and overriding steps and extending out our pipeline. So you can see code completion, well, tab completion in IntelliJ, actually having the different steps and stages that we can override and extend our pipeline. We absolutely love this, and hopefully people will like this as much as we do. We can stay here. We're just going to add a pre-build of a pre-step, and these are now just pod specs, and these get translated into our Tekton pipeline resources that Christy was explaining earlier. Okay, this is just a BusyBox container that's going to be run as a pre-step and then output an echo message. So hopefully we're going to see this. Well, I know we're going to see it because it's a pre-recorded demo, but we'll see this in the logs. We're going to commit that change of where we improved the welcome message, saying hello Barcelona, and we're going to push that up to our work in progress branch on GitHub. Now we're going to create a pull request. And this is where we do all of our collaboration, ensuring that we've got people involved in actually having that change merged and released to and deployed into a production environment. Let's try and get people collaborating before things get merged into master. Okay, we're going to do JX get build logs, because this is a way to actually interact using the JX CLI. We can tail our logs. I don't know if you can see at the back there, this is our pre-step that we added into our pipeline of Jenkins X rocks. So remember, it's using the shared build pack to build out that Golang quick start, but we added a pre-step of echoing that log, and we can see that in the logs. So it's a fabulous way to be able to extend and override steps within our pipelines. Here we've got the preview environment where we can collaborate and you get people involved who are actually sharing. Maybe that's testers or maybe that's product designers or UX folks, to be able to start collaborating and start seeing the proposed changes actually running in a real environment. So once that's, again, we can improve this using a workflow that developers are familiar with, which once that's merged to master, we automatically do another release of 002, which is automatically triggered. We can see that down there. That's going to, again, build our project with Canico, build the Docker image, push the Docker image. It's also going to generate a package, a Helm package with the Helm charts to be able to deploy that application. It's going to release that package into Chart Museum, which is a repository manager for charts. Then it makes a pull request on our staging environment Git repository. Once that's merged and approved, we can actually automatically deploy into our staging environment. Okay, that was pretty fast. There was a lot to take in. But this is, there's a lot more on the website, a lot more information. There's lots more demos as well. But there's hopefully creates a lot more questions that we'd love to talk to you about as well. Okay.
That was super cool. And so as you know, we're here at the CDF Summit. In March, we were really excited to donate both Tekton and Jenkins X to the CDF. So we're really looking forward to collaborating with a whole community of people that are focused on CI/CD to make all these things better and to make all of our projects work together really well. So if you found this interesting, you're excited, please try out our projects, consider contributing to them. Most of our projects have quick starts and they have contribution guides, so we would love to have you. And that's it for us, so thanks very much.
Thank you.